let's go. Actually, before we begin, a very quick poll. Who's still working on assignment 2 or like use the long late penalty? Yeah, cool. It's good to know. I hope people like that. Other stuff we're going to do, like people who have submitted assignment 2, we're going to do interviews this week and next week. I'm assuming that like most people, like we'll do some this week and then we'll have to get through quite a lot next week. We also have to finish up lab marking and stuff with Chinmay. And then apart from that, that's all. So just, yeah, make sure you're around to have your interview this week or next week. And we're going to have a class party next week down on the grass. I'll talk more about that at the end. Yes, both. You know, like class party where, you know, you bring something and then if you bring something, you can get entry to the party. That's your, like your ticket. Okay. Right, so everyone brings some food and then we all have fun. More like a personal gift or like food for everyone else? I mean, if you got me a personal gift, I would be very flattered. But I meant food for everyone. Where was I? Yeah, personal gifts. That's the way to go. Okay, so let's talk. We've got 2 design patterns to discuss today, and then I'm hoping to get some of these revision questions because they're actually quite interesting. And as we get towards the, are there any questions about the exam, in-person exam? Yeah. Yeah, Tom. If we're in the office, we have to like sit when you have to come basically like 10 minutes before the morning exam finishes. You'll like come and sit in the classroom. It's only like 20 minutes because while they file out and stuff, and then you go in. Yep. It's going to be great fun. Yeah. I think it's me here or like here in K17. Yep. Yes, like definitely get your extensions and your plugins for VS Code set up before the exam. How do we set it up? We just use yeah. So like go to the lab computers and do a practice run. Like what I'll say this to everyone in the lecture next week, but literally like come to the labs before the 2nd of December and do the sample exam in the labs. You can do it on VNC if you wanted to, you can do that as well. But you know, I'm the kind of person that likes to do a proper dry run. Oh, okay, right. Yeah, sorry. All the Java extensions already. I think you'll. Sorry? For the course, we installed like 5 or 6 extensions. Yeah, you might have to go through that whole setup process again, which is why I say like do it early. Yeah. We bring out any keyboards. Keyboards. Okay, so you've got to use lab computers, you've got to use lab keyboards, you can't bring your own laptop. I mean, I'm assuming you can bring it, but I don't know what happens with phones. I need to figure out with that. I'm assuming that you just keep your phones on you because you're adults and you know don't take your phones off you. Yeah. And do we bring our own tissues or do you provide? We provide lots of tissues. We're very well prepared for that. Yeah, so you can get access WebCMS, Confluence, GitLab. That's it. No, there's no reading time. Yeah. So WebCMS is everything that's being posted in forums. I mean, in yes. That's a good question. Like the forum is mainly for asking like questions during the exam, you know, like when it was online and stuff. But now like you can just like put your hand up, but I don't know how that works across multiple classrooms. So I'll get back to you. If you like in terms of searching the forum for answers and stuff, then maybe I'll let you know. But there could be something linked on, like WebCMS could have a link to Stack Overflow, but you can't go to Stack Overflow. Oh, and that's, yeah, sorry? Then like that would be the same as me just Googling. Like say WebCMS is a link to Stack Overflow. Yeah. Wouldn't clicking on that link be the same as me just Googling Stack Overflow? Yeah, exactly. You can't do it. So if I just save on the forum, that's fine though. You know what I mean? Yeah, I just need to figure out how, like, because if there's no if we're not using the forum for answering and asking questions, then there's not much need for it. What if like there's already like
help on the forum. There's like questions being answered.
Well, they're not public. They're always private. We set it to like you can only ask private questions.
Yeah.
So, yeah. Cool. All right. We can talk about the exam for all eternity. It's only 3 hours. Yes.
How hard is it like, compared to like last years? Because I've heard that
It's going to be roughly the same difficulty as last term, and we'll give you last term's exam as a sample exam. We can. Oh, I could do like a live stream in week 11 where we go through the exam. All right, shut up. Let's write some code. We've been here for 15 minutes already. So we've got this game. Okay, we've got a game. Different types of characters can move around the grid. They fight each other. When one character moves into the square occupied another, they attack, blah, blah, blah. You know, it's like kind of like the dungeon game that you guys have been working with. So we have 3 types of entities. We have kings. They can move 1 square in any direction, like chess. Queen can move to any square in the same column row or diagonal, like chess. And a dragon can move up, down, left, or right, and has a 1 in 6 chance of blah, blah, blah. Okay. So we need to implement these entities and use a design pattern to model a solution. So we've got the character class to start us off. So this is an abstract class, and a character can make a move. Have I? No, I haven't done this. Cool. Yeah, a character can make a move. What you'll notice is that like there's a bunch of stuff, you know, the character has X, Y, health points, and then it has these 2 abstract methods, attack and can move. And what you also notice is that these methods are actually called in make move. So what we have is a series of steps. Right. I forgot my whiteboard markers. Here's step 1, here's step 2, here's step 3. But some of the steps are already filled out, like this one, and some of the steps are blank. If I go on to Microsoft Word, for example, this is slower than I expected. If I go into Microsoft Word, you can see that new from template, right? So this is a template pattern where I can say, there's some parts that are filled out for me, right? It's filled out name, and there's some parts that are template that I can go back and change if I want to make a resume for me, or if I want to make a resume for someone else. You know, certain bits are already done, like the formatting and the email address and the little pictures and stuff, and then other parts, I can fill out. And it's the same idea in code where we say, usually this is an abstract class where we define an algorithm or a series of steps. And some of the steps are defined at the abstract level, and some of them we have to define in subclasses, and that's what we're about to do. So inside, let's start with king, and we'll say extends character. Now immediately the abstract class is going to force us to implement attack and can move. So now we just get to do that. So when we attack a victim, sorry, get rid of this. They can move, they always cause 8 points of damage when attacking. Cool. So all I need to say here is victim.damage. And we'll put this into a variable private final int damage equals 8. Cool. And can move 1 square in any direction. So what we get given in this can move is the change in X and the change in Y, right? Like dx and dy. What would we say here? To move like a king in chess. So we can move 1 up, 1 down, 1 left, 1 right. Yep. Cardinally adjacent. How do we say that in code? Like this. Yep. So we'll say return, or what is it? Dx equals x plus 1. There's probably there's a cleaner way we can do it. Yep. We'd say like math dot absolute value of x minus dx, and I think it's y minus dy equals 1. Oh, we need to say get x, sorry, get y. Oh, that seems correct. That's king. Let's move on to queen. So we'll say same thing, extends character. And for this one, we have a 1 in 3 chance of inflicting 12 points of damage and a 2 out of 3 chance of inflicting 6 points of damage. So if I get a number and say like, double random or rand equals math dot random, this is going to return me a double value with a positive sign greater than or equal to 0 and less than or equal to 1. So how do I turn this into a score, right? It's like it's a 1/3 chance of, what is it? And inflicting 6 points of damage and a 2/3 chance of inflicting 12, or the other way around. Yeah. Yeah, we could say, what's the rule again? 1 in 3 chance of inflicting 12 points of damage. So if rand, do you want to go less than or greater than? Less than what number? Yeah, we'll just say 1/3. 12 points. Yep. So say return of victim.damage 12. And we'll put that in the constant private final int damage I, and damage low will be 6. Oops. Oh, and I can't spell advantage. There we go. Add a constructor. And then otherwise we'll just say victim.damage. Sorry, else victim.damage. I can't spell damage. Damage low. Okay, and so for the movement of the queen, can move to any square in the same column, row, or diagonal. Any thoughts for this one? How can we represent this in dx and dy? Absolute change absolute change in x. That's fine for diagonal. What about like up and down and side to side? Sorry? Yeah. Yep. Yep. So we could say return math dot absolute value. So like what we have is here's our queen with this up or down or the side. So like we've said, the change in x minus the change in y is 0. That's diagonal. For the uppercase, it would be there's some change in x, right? But the change in y is 0. So say change in y equals 0. That's the vertical movement. Or the change in x equals 0, which is the horizontal movement. Right? Because the change in x is, sorry, I've got this the wrong way around. Sorry, if the change in y is 0, then we've moved horizontally. And if the change in x is 0, then we've moved vertically. right? Like sliding.
What about the case where the inputs don't change in X or Y?
This can be true. Things will be true as well.
Yeah,
Any other disagreements or queries? Does everyone get this? I think this is good to understand, just like the logic. So we'll say, math.abs dx minus dy equals 0, or
we have to
um,
down to like negative direction down to positive direction, right? And if they minus it would be
yes, like they have to cancel each other out. But
yeah, but if you went down and then in the positive direction, right, so it wouldn't make 0.
hang on, this is an easy way to do this. Think of algebra. You're like, if x plus y equals 0, you put absolute values around everything.
Yeah,
What does that mean?
Yeah, that's what I said. Square root. Oh, it's
X is just the same as y, right? Like if you're not dealing with negative signs or anything, it's just like x equals negative y, but in the absolute value world, then they're all just the same.
Yeah.
So what we can test for is if dx is equal to dy, then we know it's diagonal. Does that make sense?
so that's the absolute.
Yes. What do we have? Dx equals, oh yeah, so dx equals 0 or dy equals 0. Maths, American spelling. Cool. And last but, oh, there's a knight character as well. Oh, that's done for us. That's very kind. Last but not least, dragon. Extends character. Let's implement that. Let's add a constructor. Cool. A dragon can move only up, down, left, or right, and has a 1 in 6 chance of inflicting 20 points of damage. All right, let's do the damage first. We'll say math dot int rand, sorry, double. Actually, there's an even easier way. We'll say if math dot random is less than what? Yep, 1 in 6 of inflicting 20 points of damage. Okay, victim dot damage 20, and that's it. And so if it can move, what's the rule? They can only move up, down, left, or right. Oh, we messed up. This is diagonal. So this includes diagonally adjacent as well as cardinally adjacent. So let's just cheat and copy this over to the dragon class and then redo the king, right? Because this is cardinally adjacent. So for king, you can include diagonals as well. Any ideas? This is cardinally adjacent. The king, you can go this one, this one, one. One over root 2. Yeah. Oh, like the hypotenuse. Yeah. I should just check this. This is you don't you add your x and y together. But like if you have 2 is less, the root 2 is less than 2. If you add the remaining confused. So your root 2 is 1.1. Yeah. I've got to math. I've also forgotten what the answer is to this question. It doesn't really matter, but let's just say, what should we say? Pardon? Okay. I'm going to look up the answer because I've forgotten.
Like, could we say, like, yeah, absolute change in X, absolute change in Y? Like, yeah, the change in position is less intuitive than if someone is in a position that's like X equals Y was 1.2, then it's still technically right. What is
Yeah, the change in X and Y has to be an integer, right? It's like you're moving one discrete square. Okay, so this is the answer, because I cheated. So dx is 1. Oh, that's right. You just have to say either your change in X is, like if your change in X is 1, then your Y has to be less than or equal to 1, right? It's like because you moved up or down 1 or just on say on the same Y value, and then same thing in the X. So that's it. Okay, let's crack on. So this is a template pattern, and I think I can run this game actually. Can I do that? Add character. Oh, let's play the game. Where should we move to? Where are we moving the king to? I'll make this bigger. What square? Remember the movement constraints. Like, I think it's just one like that. Can we try and let's try and attack one of the other characters? Move dragon at 0, 1 to 1, 1. Oh, what? That's weird. Pardon? Can we try and attack someone else? Like that? Cool. We attack another character. Essentially what's important though is that it goes through all the characters and then makes a move for each one. And this will run our algorithm inside character.java, which is completely the same, except for the parts of the template that the classes individually fill out. That makes sense to people? Any questions? Cool. 629. Okay, let's get on with the next part, which is an evolution requirements. So now we say, okay, your game did that before. Now we wanted to do some new stuff. We wanted to add in like defense parts, essentially. We get helmets, chainmail, templates. Let's just do the chainmail and decorators. So at the moment, I really need a better white. Does anyone have any whiteboard markers? I always carry my whiteboard marker. You whiteboard marker? Yep. At the moment we have abstract class, and then 1, 2, 3. Oh, and we need to talk about something else important with template package. I'll do that. What we want to be able to do now is define an add-on. And like there's lots of ways you could do this. This isn't probably the way I would actually do it. The way I would actually do it is like how in the inventory is done the assignment to starter code, where it's just like you have a player has a list of items and you can just go through and apply the parts from those items. But today we're going to use the decorator pattern, which allows you to just add new items in extensively. And we do that by creating a new file. So what we're going to need to do is change the inheritance structure to be from this, say, well, what I want to do is have a chainmail decorator. And the chainmail decorator is it's indistinguishable from any other character. So what you can have is like, here's my king. Right, good old Charles. And we'll decorate Charles in a chain map. And then we could say, okay, well, I actually want to decorate them again in a chest plate. And now we have another chain map and another chest plate and so on and so forth. The problem with that is you don't know what you can't say, well, like if I'm decorating a chest plate, I don't know what type or what possible interface to decorate. So we need to say, let's define a type which it doesn't matter what it is. It doesn't matter whether it's a king or a queen or a dragon or a certain type of chainmail or chest plate or helmet. The interface is all the same. We're going to do that by introducing another layer of abstraction, which is going to be an interface called character up here. Character. And then we're going to change this character abstract class to be character base, which is your king, queen, dragon. And this is going to implement that interface. And then we're going to have another interface. Oh god, which my whiteboard. Here's my other interface. Which also implements character. And this is going to be our types of decorators. We have one decorator up here and one here. This is going to be chest plate, and this is going to be chainmail. And these both inherit from a decorator class. And importantly, the decorator is also a character. So what I can do is say, well, I'm going to wrap this thing, but I don't know what I'm wrapping. I'm just going to be wrapping a character. I don't care whether it's a character base or a decorator because they all implement the same interface. Who's confused? No one. You're all very clear. Okay. You should be confused. Let's write this in code. So we'll start with we'll start with making this an interface. It's a public interface character. And there's all these problems, like we've got to move a bunch of stuff. So let's do some refactoring. We'll call this character base .java, which implements character. And this is going to add our unimplemented methods. Now all this stuff here, like the constructor, we just move. Like so. And then here, we just turn these into normal interface methods. So they don't have an implementation. Here's the damage. Here's the make move method. Copy. So all we're doing is just moving everything into the subclass. This is still going to be abstract because we don't want to instantiate it directly, but it will implement this interface. So I just need to say here, return health points and return X and return Y. And we'll say health points minus equals damage. Sorry, points. I think I'm missing something from here. No, that's not right. Okay. There we go. And then we just say victim dot damage points. Nope. Actually, I think this one. Oh, this one we need to make abstract. But because we're implementing this interface character, they're already defined here. So we're just going to say get rid of them and make the subclasses do it. Right? You can essentially forward on methods to implement from interface to subclasses. So you have like your interface and an abstract class, and the interface it says implement these three methods. And the abstract class, because it's abstract, can't instantiate it. You can just say, well, I'm not going to do any of them. I'm going to make the subclass do it all. So they have to do 1, 2, 3. But maybe you could say, well, I'm going to do 1 in the abstract class and 2 in the subclass. Up to you. This extends here and this extends in each place. Okay, let's keep going. Now we kind of have to refactor all our inheritance here as well because this isn't good. ToString app override. We'll get rid of this. And put it here. Okay, so that's looking fine. Now we just need to fix our subclasses, which should just involve changing character to character base. Woohoo, that looks really good. No more red errors. So we've done like the right-hand side of that inheritance structure. Now let's do the left-hand side where we actually implement the decorators. So I'm going to say character decorator .java, and this is going to be an abstract class. And what it's going to do is, so we've got chainmail and chestplate, our 2 different types of decorators. Let's do those first. Chainmail decorator. And this will extend character decorator. And our character decorator will implement character. This is the crucial bit. This is quite a long example, but if you take nothing else away from it, the decorator has to implement this abstract interface. So you could have a character base, that's a character, and then a decorator is also a character, and you don't care which one it is. And we'll see why in a second. Now here, this is going to force us to implement some methods. We are not going to implement all of them in the subclass. We're going to do some of them in the superclass. So let's move all this stuff here. And copy that and put it in character decorator. Now, why is this giving me red lines? Can't tell. Okay. Oh, I see. There we go. Cool. So now we have the stubs for our decorator class. What do you think when you decorate something, what needs to be on the inside? Yeah. Yeah, so like when you decorate something, it's like when you wrap a present. Oh yeah, Luke.
Like for this situation for the character itself.
Yeah, so we're going to store a character in here. We're going to have a composition relationship. So what you end up getting, and it's really, I wish my bookmark was better, but when you decorate something, you just have something to decorate. You've done like decorators in Python. They're just like a little thin wrapper around a function. And it's kind of what we're doing here, except instead of wrapping a function, we're wrapping a class. And how this works is that the character base actually is composed, sorry, not the character base. The character decorator is composed of a character interface. So it implements this interface, but it also is composed of that interface. And this could be another decorator, or it could be a character base, or it could be a decorator with a decorator inside of another decorator, and you hold all these layers, and then eventually we get a different colors. So what we're going to say here is private character, and then most of these methods here, you say, well, what are the health points? I don't know. I'm just like a bit of chainmail or a chest plate. I'm just going to forward this on, and eventually it's going to get down to the actual character itself. So I'm going to say return character dot get health points. So I just delegate, pass the parcel. Same thing here. return character dot get X. And here. Dot get Y. When we take damage, because the helmet itself isn't taking damage, right? The underlying character is. We're sort of stuck up in this layers of wrappers, so we need to pass it all down. Character dot damage points, and actually this doesn't return anything. Same thing here. Character will return dot make move, and just pass along all the parameters. Okay, now here is where things get interesting, because when we wear a chainmail, we reduce the amount of damage by half, and we caps the amount of damage to 7. So actually, this seems fine, but we're going to have to change this in one of the subclasses. I think in this case, the attack method will be the same. So you say victim, character dot attack victim. And then can move, we're going to make this abstract. Sorry, I've confused myself. Chest plate caps the amount of damage to 7. We're not going to make this abstract, but we're going to end up overriding it in one case. So we'll return character dot can move dx dy. This class is very, very benign, right? All it's doing is storing a character and then just passing everything on. That's intentional, because inside the decorator classes, what we're going to do is override some of this. So for the chainmail, reduces the amount of damage by half. So all I'm going to say is at override, and then copy this prototype from up here. What's really neat is that we want to be able to access the character, right? Again, composition relationship. The decorator calls another character. Again, just has to compile that into that. In the subclasses, you want to say, okay, well, now when I take damage, it reduces the amount of damage by half. How can we do that? What approach do you write this?
It's like not really makes sense because of the character that we using to attract. We want to talk about the character where it happens.
No, in this case we are like this is about taking damage. So you take half the damage in this case. Yeah, Tom. Yeah, I like your thinking. But Java doesn't. What's the problem here?
Yeah, is it trying to decorate it?
No, that's the part. Yes, I was we do getter, but is there a better way? Like instead of, because like if you have a getter here, it's like you kind of, what's the point of the abstraction? Like there's literally no point in the abstraction then, in the sense that, yeah, you stole my thunder. Like if you just put a getter here, it's like you're just giving them literally everything out in the path anyway. It kind of makes the path pointless. So instead of exposing the underlying representation to the child classes, we could say, well, we have this damage method, right, which delegates the damage to the character. We can access this. So let's use this as like a proxy and say, well, super dot damage. Remember, we're overriding this method, but we can access the original implementation by calling super. So this will go to super dot damage, go to definition, points over 2. All right, that's a chainmail one. Let's do the chest plate, which is a bit more interesting. Chest plate decorator Java. Okay, so it caps the amount of damage to 7, but also slows the character down. We'll say extends character decorator. And notice like we don't actually have to, it's not forcing us to implement anything because we've actually implemented everything already in the abstract class. But we want to override some of the stuff. So we're going to override can move and attack. For attack, caps the amount of damage to 7. What can we do here? Yeah, there's another way. There's a nice function we can use. It's a maths function. Yep. Max or min? Who reckons max? Who reckons min? Okay, so let's try max. So say what are we gonna say? Okay. So we've settled on min. All right, what code do we need to write then? Yep, super dot damage. Math dot min. Sorry. I'm sorry, this should be damage. I've copied the wrong prototype. Int points. Points. Private final max damage equals 7. Int. Cool. That looks good. Now for this one, this is where things get interesting. If the character is otherwise capable of moving more than 1 square at a time, then this armor restricts each move to a distance of 3 squares by Manhattan distance, which you're all very familiar with from assignment 2. So the first thing is, we need to say, well, independently of this decorator, can we move already? And again, this is where we're delegating as the decorator. You say, well, look in the underlying layers, right? If it's the king or queen or the dragon can't actually move to place to begin with, then obviously it's not going to work. So what can we do here? We need a way to say, I'm actually going to go and look at the underlying object that we're decorating and look at the result of that first. And then we're going to apply some more stuff around it. You need the same idea, right? Super? Yep. How do I say, if the underlying thing we're decorating isn't going to work, then just return false? Yep, we're going to do some method forwarding. What can we say? In the superclass?
Yeah. From the actual.
So we're given dx and dy, and we want to say, okay, we're inside the chest plate decorator. I want to forward this on to whatever thing we're wrapping, right? The only way we can access the internal character is via which class? This one, right? The decorator. This is the internal character. Now notice that this already has a can move. Again, we can sort of proxy it, right? So, well, I'm going to find out whether the character can move by calling this can movement. So how do we access that from this class? Yeah. So we'll say if not super dot can move dx dy, then what do we do? Yep, return false. Right? If we already can't move to that location, then all bets are off. It's like, well, there's no point in going any further. It's like your you know, when we did the equal back in week 2, we say, well, if it's null, we need to return false. This means return false. Same thing. Okay, so if we can't move, okay, let's say we can move to the location. We now have this additional constraint where we say, well, if we work otherwise capable, then this armor restricts each move to distances of 3 squares or less by Manhattan distance. Manhattan distance is just like the number of squares that you've moved, I'm pretty sure. Unless I'm getting, yeah, it's not like, yeah, it's not Pythagorean. So what can we say? Anyone?
Change X, let's change Y, let's do it.
I was thinking that, but I don't know if like, because you could go 1 across and 2 up, and then your Manhattan distance would be 2. So maybe we take the max. So we could say return math dot max get x minus dx get y minus dy. And we also need to do some absolute values here as well. I think that's dot abs. And what do we say? Less than or equal to 3. Okay. That looks fine. I don't have any code to actually test this out, so we'll assume it works. The point is though, we are essentially adding these very sort of thin wrappers around these parts. Decorator patterns really useful. Like just the idea of decoration, probably we're pretty familiar with, is useful where you can say, well, you know, maybe I've got a function and I'm going to make a little wrapper, which is an API endpoint. Like, right, we did that in 1.5.3.1 projects. We can make wrappers for all of this little class layer and then delegate rest. Same thing here. We just say, well, here's a layer of logic related to, you know, the chest plate. Here's a layer of logic related to chainmail, which is part of this decoration. And then underneath we have the base object. Does that make sense, everyone? Yep. Any questions? So this is like an object-oriented sort of approach to decoration. In Lab 8, do a mix sort of like an OO decorator, then a functional decorator. The functional decorator is quite interesting where you get into like the string. You have to include strings in Lab 8. And you start to sort of see the sort of chaining of operations where, like, you know how like a function is like a toaster, right? Is my whiteboard marker gone? Is instead of having like, you know, layers and layers and layers of objects all wrapping one another, what you have is either function, and that chains onto another function, that chains onto another function, like in this big pipeline. And because they all implement the same interface, just like we could do with the character, is you can add in as many as you like. So you know, I'm actually add a new set in the functional chain here. Cool. We've got 5 minutes. Let's do some revision questions. This should be useful for the exam. So I'm going to go to lab 9 and revision questions. Is it this one? Nope. Lab 9. It's pretty small. These are all like revision exercises for exam practice. Sorry, yeah, Chelsea.
So is that a sample exam?
Yes.
Okay.
Yeah, we're going to give you last term's exam as a sample exam. So it's pretty much going to, it's the same format, very similar. So yeah. This is all just like stuff to help you out as well. Lots of previous exam questions and lab exercises. Let's do pardon? No. That's my job this weekend. Yep. Sorry.
I'll remember that.
Okay, let's let's do this one. Or you close your eyes, or look at it for like detection. You got your 10 seconds to discuss it, and then you'll have to make an answer. The design pattern used to enhance a component's functionality dynamically at runtime is. All right, close your eyes. Who says composite? Who says decorator? Who says abstract factory? And who says observer? Open your eyes. I wish people would actually open their eyes. Probably we're gonna do like heads down, thumbs up for the next one. So the answer is decorator. And something I didn't talk about with this is that one of the big ideas of the decorator pattern is you can at runtime say, I'm going to now add another chest plate. I'm going to add a change. So you can keep adding it as you go dynamically. It doesn't all have to be dictated from the start. This is also brings us to another point which I need to mention, that there's a difference between, a lot of people say, oh, you know, here's the scenario, and they think it's a strategy pattern, and it's actually a template pattern. Does anyone know the difference between the two patterns conceptually? Yeah.
So like with template, you really use it when there's a lot of things that's complicated, like a lot of functionality that you don't have to, you don't want to repeat again. Like for example, like the algorithm that might templates something based on changing conditions, but the algorithm stays the same. So you use a template to show that because most of the algorithm stays the same.
What if you had like the charging one? We say, well, here's how we're going to charge. Here's our like our checkout algorithm. You check out, and then there's one step where it could be happy hour, it could be holiday, it could be standard. You've got this kind of similar thing, but this is a strategy pattern as opposed to a template. How come? Right, this is your strategy pattern. Right, strategy pattern. What's the thing? Think about the game we were just talking about, where you have kings and queens and dragons, right? This follows the template of character. What's something that's different about that versus the restaurant way of charging people? Is if I say, okay, this thing is a king, is that ever going to change? Locally according to the rules of the game? No. When I say, okay, I'm going to charge people with the happy hour strategy, would that change? Yeah. And like the thing with any strategy is, you know, like back when we did it, it's like, you know, your strategy for doing COMP2511 is like you study whatever. And then if the strategy is not working, or at any time you can change the strategy. The template pattern, once you've done it, that's it. There's no change. So in that sense, the template pattern is static, whereas the strategy pattern is dynamic. So if there's any if there's any information in like a question, like a question in the exam that says, you know, here's a scenario, blah blah blah. What's the design pattern you can use? And you'll have to pick a design pattern and justify your choice, essentially. So the difference between template and strategy is if there's something in the scenario that says blah blah, and these can change, right? There's an illusion that there could be, okay, well, we do the happy hour strategy, and we do the holiday strategy tomorrow. You can chop and change strategies at any time, whereas template, it's fixed. Does that make sense? Yeah.
Well, like an abstract class be a template pattern because you have the class itself and all the objects sort of take the methods from that class and just really change.
It's not like you can have an app sorry. Here's our strategy pattern. You can have an abstract class because I have 3 different strategies, but maybe some of the strategies are common. Like there's some common elements to it. So you put all the common stuff in the abstract class, but then all the strategy specific components, you know, here's again 1, 2, 3. The key thing is up here in the person or the client using the strategy is that at some point they're going to go, you know, if blah blah blah, change strategy. In a template pattern, that doesn't happen.
Could you create the strategies in a template pattern and then have
Yeah, go on.
for example, you have king, queen, and whatever the other one's called.
Yeah.
Like, would you sort of have that as the strategy, sort of follow that template, and the actual class itself can change.
Then it would just be a strategy pattern. Like if you introduce a rule of the game that said, okay,
Yeah, with chess, you know, like,
Yeah.
like the rook, like you can like change the pawns to whatever thing you want. Would that be a strategy pattern, or would that just be a template pattern? Because all the class, all like the whatever pieces have specific rules assigned to them.
yeah, that's a strategy pattern. That's what I was about to say. Like if you use something and say, well, okay, a king can turn into a queen, or a queen can turn into a dragon, or whatever. Or, you know, if there's some interchangeability between your different entities, then it becomes a strategy pattern, right? Because you're dynamically chopping and changing functionality. Good question. Cool. Let's do. Oh, we're running out of time. Let's do two more. Oh, let's do this one. Which of the following is not a code smell? You got 10 seconds to discuss it. A lot of discussion. You've got classes that not only passively store data, but have methods that operate on it, large conditional logic blocks, methods making extensive use of another class. Okay, heads down, thumbs up. You don't have to put your thumbs up, just put your heads down. I want to see you actually closing your eyes, please. Because, you know, so that other people don't. It doesn't influence your decision. Okay, who thinks it's classes that not only passively store data, but methods that operate on the data? Which of the following is not a code smell? Who thinks it's large conditional code blocks? That's not a code smell. Who thinks it's methods making extensive use of another class is not a code smell? All right, eyes up, heads up, stand up. Don't actually stand up. Okay, the answer is 1, because like this is what most classes do, right? Is they store data. I don't know why it says passively. I think what it means is like it doesn't just store data and do nothing else, but it has methods that operate on the data. That's how all classes work. That's like the premise of OOP. So that's fine. Large conditional logic blocks, very bad. Some of you in assignment 1, massive code blocks. Not good. We like to keep our code concise and clean. And then number 3 is what design smell? Does anyone know? Feature envy. Yep. You got a class that's really envious of this other class. So I want this, give me this, give me this, give me this. You think maybe let's take that bit of logic and push it into the class itself so it can do its own thing, rather than having to ask it for stuff all the time. Okay, let's do one more. I really like these, so I think it's good that we do them. Let's do this one. Actually, let's do question 11. When code has sets of variables usually passed together in multiple places, this is an example of the code smell: duplicated code, inappropriate intimacy, data clumps, and lazy class. Give you a few seconds. All right, heads down. Heads down, thumbs up. Okay, who thinks it is duplicated code? Code has sets of variables usually passed together in multiple places. Who thinks it's inappropriate intimacy? Who thinks it's data clumps? Who thinks it's lazy class? Who just didn't put their hand up? All right, heads up. So the answer is data clumps. I'll go through each of these. Like the thing about the code smells is they're quite illustrative. So duplicated code, you're very familiar with that. Inappropriate intimacy is kind of like feature envy, but it's just sort of conceptually two classes getting a bit frisky with one another, right? It's like they sort of know each other a bit too well. there's this like joke in C++ that you can have these friend functions, and the friends live outside the class, but they can access the private members of the class. So there's a joke that's like, oh, you know, friends can access the private parts of each other. Very funny. But it's this general code smell that there's a bit too much going on in interchange between two classes. The third one is data comps, and this is the answer. You know, when you like get, you know, like if you've ever made eggs and you're like cleaning the pan and you get these kind of clumps of egg on the pan afterwards, it's really sort of disgusting, you know, things, and it's annoying to wash up and stuff. This is like the same thing where you have bits of data that just sort of stick together and kind of travel around with each other around the code base. So that's a code smell where it's like maybe those two should be encapsulated in some sort of object, or there's some sort of underlying problem that this data const speaks to. And then the last one is lazy class, which is like a class that just kind of doesn't do much, and you know, you're not really sure whether not really sure it's doing enough work to justify its maintenance. I feel like this should say the word existence, but I don't know. Anyway, are there any questions on anything we talked about today? Template, decorator, and some code stuff. We talked about examples, daemons, and stuff. Awesome. Let's wrap it up there. If you have done assignment 2, get ready to be interviewed. And it's first in, first served.